Okay, welcome to lesson 2 of chapter 6, 6.2, which is titled Bisectors of Triangles. Okay, when three or more lines, rays, or segments intersect in the same point, they are called concurrent lines. Okay, that's important to know. So when they intersect at the same point, they are called concurrent lines. So for example, line L, line M, and line N are concurrent because they intersect at the same point, which is, I would say, point P. Okay, just to give you a visual. The point of intersection of the lines, rays, or segments is called the point of concurrency. So in the diagram that I drew, that would be point P. P would be considered the point of concurrency. In a triangle, the three perpendicular bisectors are concurrent. The point of concurrency is the circumcenter of the triangle. Okay, so let's dissect that last part a little bit more. The perpendicular bisectors of the sides of the triangle. That's what we would want to add here. The three perpendicular bisectors of the sides of the triangle are concurrent, meaning they are going to intersect at a point, and the point that they intersect at is the point of concurrency. Okay, so if in a triangle you draw the three perpendicular bisectors of the sides of the triangle, where they meet is called the circumcenter of the triangle, and that is illustrated in this diagram. So here, point P is where the perpendicular bisectors of each side meet. So point P would be the circumcenter, and the circumcenter theorem says that that point, P, the circumcenter, is equidistant, is equal and distant from the vertices of the triangle. So, in other words, P to A, the circumcenter to the vertex A, is equal in length to P to B and P to C. So, if I told you that PA was 13 units long, you know that PB is 13 units long and PC is also 13 units long. Okay. The circumcenter P is equidistant from the three vertices of the triangle. So P is the center of a circle that passes through all three vertices, because the distance from that point is going to be the radius of the circle, right? The radius of the circle here, 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 and here, as shown in these pictures. Now, the location of P is going to depend on the type of triangle. The circle with center P is said to be circumscribed about the triangle, so it's around the triangle. If we have an acute triangle, then point P, the circumcenter, is inside the triangle. If you have a right triangle, then point P is on the triangle, like we see here. And if you have an obtuse triangle, then point P is outside the triangle. Okay, so those are the three cases. All right, let's look at this first example. Find the coordinates of the circumcenter of triangle ABC with the vertices given. Now, if I want to find the circumcenter, there's three things I need to do. Well, I should say one thing that I need to do, but 3 times. I need to find the perpendicular bisectors of the 3 sides of the triangle. Okay, that's what I need to do if I want to find the circumcenter, because where those perpendicular bisectors meet will be the circumcenter. So let's begin just by plotting those points. So we have 0, 3, which is here. 0, -1 here. And lastly, 6, -1. Oh, wait a second, I plotted that one wrong. 0, -1 is here. And then 6, -1 is here. Okay, so this is, there you go. This is triangle A. B, C. Okay? Now, if I want to find the circumcenter, I need to find the perpendicular bisectors of each side of the triangle. So, for side AB, this part isn't too bad. The horizontal and vertical lines aren't too bad. Segment AB is a vertical line. So that means the line that's perpendicular to it will be horizontal. Okay? So I could draw a line perpendicular to segment AB like this, like this, like this, like this. But it's not that I just want a line perpendicular to it. I want a perpendicular bisector, meaning it's going to cut segment AB in half. Now AB is 1, 2, 3, 4 units long. So if I want to cut it in half, then this line right here will be perpendicular to segment AB, but we'll also cut it in half, okay? So that line right there is perpendicular to AB and cuts it in half. This piece is equal to this piece. Okay, so I did that once. Now I need to do it for the other two sides. So now let's do segment BC. For segment BC, let me just do a different color. BC is a horizontal line. I'm going to abbreviate that, which means the line perpendicular to it will be vertical. Spelling that wrong. Vertical. Okay, so again, when I draw that line, I could draw it here, here, and so on, but I need it to be halfway. So 1, 2, 3, 4, 5, 6 units long, which means the line perpendicular to it is going to go right here. Okay, because that's exactly halfway. All right, now the last one is a little bit harder, but not too bad. If we want a line perpendicular to segment AC, since it's neither horizontal nor vertical, I have to find out what the slope is. So line or segment AC has a slope of, let's see, we're going down 1, 2, 3, 4. And we are going to run 1, 2, 3, 4, 5, 6. Simplify that, and that's negative 2/3. Okay, so the line perpendicular to it will have a slope of positive 3/2. Okay, so I'm going to I'm going to start at a point A, and I'm going to go up 3. So 1, 2, 3, and right 2. 1, 2. Actually, not there. What am I doing? Sorry. Ignore that. I have to start from the halfway point of AC. You could do the distance formula to figure that out, but I also can look at where the purple and blue line are meeting and know that my circumcenter has to be at that point. So starting from there, I'll go up 3 and over 2 instead to make my life easier. So there. And there. So this point right here is the circumcenter, is point P. Okay, so the circumcenter is at 3, 1. Okay? All right, moving on to the next one. Just as a triangle has 3 perpendicular bisectors, it also has 3 angle bisectors. Okay, so the 3 angle bisectors of a triangle are concurrent, meaning if I draw the 3 angle bisectors of the angles of a triangle, they're going to meet at a point. The point where they meet is called the incenter. So the angle bisectors of a triangle meet at the incenter. Meet at the incenter, okay? So if you look at this diagram here, if I draw the angle bisector of angle A, the angle bisector of angle B, the angle bisector of angle C, they meet at this point P, which is what we call the incenter, okay? And as a consequence of that, there's a special relationship that we have, which is that the incenter of a triangle is equidistant from the sides of the triangle, okay? In other words, point P is equal and distant to side AC, to side BE, and to side AB. So if I tell you that segment DP is 14 units long, then PE is 14 units long, and PF is 14 units long. So this part is important. And actually, you should probably highlight this section up here as well. And let's just label this. P is the circumcenter. Okay. Formed by perpendicular bisectors. Okay. Here, point P is the incenter, and it's formed by angle bisectors. Okay, a lot of information to know in this lesson. All right, in the figure shown, ND, so this segment right here, is equal to 5x minus 1, and E is equal to 2x plus 11. Find NF. Okay, well, if we look at this picture, what do we know? Based on the markings, we know that this angle is being cut in half. So AN, ray AN, is the angle bisector of angle A. Something similar is happening over here. So we have another angle bisector, and the same thing is happening over here. We have a third angle bisector. What that means is point N here, so point N is the incenter of the triangle. Okay, so because it's the incenter of the triangle, I'm going to think about this theorem. If it's the incenter, then that means the distance from point N to the sides of the triangle, is equidistant or equal and distant. So that means that NE is equal to NF, which is also equal to ND. Okay, all three of those are equal, so you can add the tick marks if you want to. And remember, when you talk about distance, it has to be the one that creates a 90-degree angle with the side. Okay, so that's why I'm not looking at NG. Okay, if they're all equal, then I can just plug in. NE is 2x plus 11, ND is 5x minus 1, and I can solve this to find that x is 4. And then if I plug that in to one of my expressions, I get that ND is 19 units, but if ND is 19 units, then NE is 19 units, and NF is 19 units. Okay, so that's all you have to do for that one. All right, moving on. B, can NG be equal to 18? Explain your reasoning. Well, since we know that NF, NE, and ND are all 19 units long, and that this distance, I'll use a different color, this distance is the shortest distance to the side of the triangle, right? Which is why it's what we refer to when we're saying the distance. It's the shortest distance, so that means NG couldn't be less than it. Okay, so since NF equals 19 and is the shortest distance to side AC, NG cannot equal 18 because it's less than 19. Okay? All right, so far we've done circumcenters, which are formed from the perpendicular bisectors of a triangle. We just looked at incenters, which are formed from the angle bisectors of a triangle. Let's keep going. Because the incenter P is equidistant from the three sides of the triangle, a circle drawn using P as the center and the distance to one side of a triangle as the radius will just touch the other two sides of the triangle. The circle is said to be inscribed within the triangle, so the circle will be inside the triangle, whereas with the circumcenter, the circle is circumscribed about the triangle. It's outside. The circle's outside the triangle. Okay? All right. City officials want to place a lamppost near the streets shown so that the lamppost is the same distance from all three streets. Okay, the same distance from all three streets. In other words, the same distance from all three sides of the triangle. Okay? Should the lamppost be at the circumcenter or incenter of the triangle piece of land? Explain. Well, if I want the distance to be the same from all three sides of the triangle, I want to use the incenter, not the circumcenter, because the circumcenter is equal in distance to the vertices of the triangle, the angles of the triangle, where the incenter is equidistant to the sides of the triangle. So we'd want to do the incenter, okay? Because the incenter is equidistant to the sides / in this case streets of the triangle. Okay? And that's it.